Okay, so welcome to our first lesson on objects and states. Well, previously we talked about objects, which are things that exist, and it can be as simple as a book or as complex as an aircraft. It can also be intangible, like data or ideas. Objects are represented in OPM by rectangles with a green border by default. As you can see here, we've got the book object, aircraft object, data object, and idea object as well. And you can see some of them have a shadow and some of them don't. We'll review the answer in lesson 3 of this chapter, but for the meantime, why don't you ever think why this is the case? In terms of naming conventions, objects should always be nouns with the first letter of each word capitalized. So if you have control system here, where system is not capitalized, you should capitalize the word system. And secondly, objects should be in the singular form. So if you have tools, you should say tool set instead, or if you have passengers, you should name it as passenger group instead. The convention is to use the word set for inanimate or non-living objects and use the word group for animate or living objects to express the plurality. The reason behind this convention is that we want to make sure the OPLs are grammatically correct. If you remember, when we create anything on the canvas in OpCloud, a corresponding OPL sentence will be generated. So in order for that sentence to be grammatically correct, we need to follow this kind of conventions. Now, another very important rule is that every object in an OPM model must be uniquely named. This is because its name is its unique identifier. So let's say if you have a data object in one diagram SD1.1, if this data object appears in another diagram SD1.2 as well, these two objects will essentially be the same object. So it persists throughout the model and it carries forward all of the relationships, all of the things that have happened to this particular data object. So if you don't meant for these two to be the same, for example, if you have flight data and if you have communication data, you would need to name them appropriately in order to keep them separate. And this is also why objects in OPM tend to have quite descriptive and sometimes long-winded names as well. So now let's take a look at how we can create an object in OpCloud. So now here we are in OpCloud, and feel free to also fire up your OpCloud so that we can practice together. To create an object in OpCloud is super easy. You just have to find the object representation at the top and drag it to your main canvas. And you can see here we've got object 1 created for us automatically. If you have this auto format option toggled on, then the name that you assign to this object will automatically be capitalized. And if you create any plural items without using the word set or group, then OpCloud will also automatically warn you as well. So let's create an object called aircraft. And this is what the object will look like in OpCloud. So now that you know how to create an object in OpCloud, let's look at states. States are situations or conditions or statuses that an object can take at any given point in time. For example, if we have a locked object, it can be in two states, locked or unlocked. And states are shown in brown rectangles or rounded rectangles inside the object. When you create states for an object, the OPL generated would read log can be locked or unlocked. For the naming conventions, we usually name states in nouns or adjectives, and we don't need to capitalize them as well. Now, states can also be designated as initial, final, current, or default, and they can also be assigned to the same state as well. So let's take a look at the locked object. I may say that the locked status is the current status and is also the initial status, while the unlocked state is the final state. The OPL would then change based on these designations. For example, in this case, it would read lock is currently at state locked, and state locked is initial, state unlocked is final. Another useful tip is that you can suppress these states as well. So why is this useful? Well, let's consider a bus object in a model where we're trying to explain its journey. It may have the states of origin, stop 1, stop 2, and destination. Well, in one particular diagram where I'm trying to model its journey specifically from stop 1 to stop 2, now in this case, the origin state and the destination state are not relevant. They don't add any value to this particular diagram or this particular page in the story that I want to tell. In this case, I can suppress these two states and they will become a smaller state representation in OPM with the number indicating how many states have been suppressed in it. The OPL would then change into bus can be stop 1, stop 2, or at one of two other states. This ensures this diagram is focused, clear, and concise, and without losing any rigor, because we know that there are still other states in this particular object from the representation and also from the OPL as well. So now let's take a look at how we can create states and designate them into different statuses as well. Let's take a look at our log object in here. To create a state, all we need to do is click onto the object that we want to create the states in, and either find the Add States button from the three-dot menu, or on the top level toolbar, which is in here. And once we click the Add States, you can see two states have been created, and we can go ahead and type in logged and unlocked in here. So now we have got two states. If you need more states for this object, just click the Add States button again and again, then you have more states. Or you can also remove these states if you don't need them. And this is how we can create states in an object. Now to assign the state as either initial, final, current, or default, just click onto the state and you can see different options have come up on the top menu bar. And we can click this to set this log state as initial and also set it as current, for example. Then we can go to unlocked and set this as final. And you can see the OPL would change based on all of these designations. Now, if we don't need the unlocked state in this particular diagram, we can click onto the state and from the three-dot menu, find the suppress option and click onto it. And you can see the state is now encapsulated in a smaller representation. And if you hover over it, you can see the suppressed state as well. And the OPL would change into logged is logged or add one other state. And this is how we can create states in OpCloud. Now that you know how to create a state in OpCloud, let's take a deeper look into states. States only exist in the context of the object they belong to. So for example, for the log object, we have the logged and unlocked states. But if we take away the log objects, the two states on their own mean nothing because what is logged and what's unlocked, we won't know. So states only exist within the context of their object. States are also mutually exclusive as well, meaning that an object can only be at any one of its states at any given point in time. You may have heard of this Schrödinger's cat from quantum mechanics, where the cat is both alive and dead at the same time before an observation is made. Fortunately, OPM is built on conventional physics, which means that we can only have mutually exclusive states. For example, for an object called person, we may want to have the life stages as its states. Let's say toddler, child, teen, adult, and elder. These states are fine because they are mutually exclusive. You can be a very childish adult, but still physically, you can either be an adult or child, but not both at the same time. Now, what if we have different descriptors for the person object? Besides age, maybe we want to also describe its gender as well. In this case, you would need to separate them into different objects. For example, we can have the age object as it is, with all of the life stages, and we can also create another object called gender with the states male and female. And then we can connect them using an exhibition link to the person object to indicate that these are the attributes person exhibit. By separating these different descriptors into different objects, we can make sure the states within these two descriptors are mutually exclusive. And together, this is known as a compound state. Now, states can also be a value state as well. If an object has a value state, then it will not have multiple states in it, but it will only have one single state. However, this single state can have changing values. Let's say I don't want to use qualitative life stages to describe the age, but I actually want to use a more precise numerical value to describe this. I can use a value state and actually put that numerical value within this particular value state, and the OPL would read age is 23. Now I can change age to other values as well, and the OPL would change depending on this particular value. And value states are very common in simulation and computation, where these values are programmatically changed based on some predefined logic.